Welcome to the next video in the linear equations and linear graphs section of Algebra 1. This one's going to be about slope-intercept form of a line. We're going to go through the formula, some examples of how to use it, and some examples of converting to and from slope-intercept form from the other forms that we've learned. So first, let's just show the formula. Let me get my pen here. The formula is y equals mx plus b, and each of the things in this formula have a meaning. So the y is the y variable. This is going to stay as a y. The x is the x variable. It's going to stay as an x. No matter what equation you have, the x and the y will still always be x and y. However, the m and the b, I put them in red because they're going to be numerical values. So for a particular equation of a particular line, you're actually going to put in a number right here in place of m, and the number you put in is going to be whatever you found for the slope of that line. So like rise over run, if you remember. And the number that you put in for the b is going to be whatever the y-intercept is that you found for that line. Remember, the y-intercept is where the line crosses the graph on the y-axis. Sorry, where the line crosses the y-axis. And it's also the starting value. If you think about it as like a sequence or a series of terms, it's the first value, the starting value that you have. So m and b will get replaced by numbers, x and y will not. So for example, you might have something like y equals 2x plus 5. That could be an actual equation of a real line. So y equals mx plus b is just the formula that leads you to an actual equation of a line. So this would be a line with a slope of 2 and a y-intercept of 5, for example. Okay, so let's try to see the connection between this formula for slope-intercept, which I'll write again, y equals mx plus b, and the formula that we already had for linear sequences. If you remember that, it was the final value equals the initial value plus the rule times the number of steps. Okay, and I want to show you how these are actually essentially the same formula. So the final value is the output or the answer that you get. The initial value is the starting value. So the initial value is just like the y-intercept. Okay, the final value is just like the output or y value. So this is essentially your output, the last value in your sequence, or the whatever value you're trying to find, the term, like the 10th term or something like that. This is your starting value. So the output is like the y variable. The starting value, we've already said, is the y-intercept, which is b. The rule, we've already said, is the amount that you add each time, which is how much you go up by each time, which is the slope. Okay, which is m. And the number of steps, this one is maybe not as easy to see. The rule is the slope. Sorry, the number of steps is actually the x variable. So if you imagine you have a graph, you start here at 0. Then if you're going over to like x equals, say, 4, since you're always starting at 0 on the x-axis, then the number of steps forward, 1, 2, 3, 4, so your number of steps always equals your x value on the x-axis. Since on the x-axis you always start at 0, then to get to, say, x equals 10, you have to take 10 steps forward. To get to x equals 117, you have to take 117 steps forward. So this number of steps forward is actually just your x value. Okay, so you can see right away that you've got y equals b plus, here's m multiplied by x. And of course, if you just change the order of these two terms, since they're added together, the order doesn't matter, you can write y equals mx plus b. So this is not really a new equation, it's just a different way of thinking about what we've already learned. When you think about it in terms of a sequence, you think about the number of steps you took and the value of that term. When you're thinking about a linear equation for a graph of a line, you're thinking about an input and an output relationship, but mathematically they're the same thing. Okay, so let's try some examples now. So just like with a sequence, if we knew the slope for a sequence, which we called the rule, and the y-intercept, which we called the starting value, we could graph it, and we could write an equation for it. So instead of giving you the rule and the starting value, we're giving you the slope and the y-intercept, but it's the same exact thing. Okay, so if the slope is 2 and the y-intercept is -3, we can write down our formula, y equals mx plus b. We can fill in what we know. The slope is 2, so y stays as y, it's a variable. M is my slope, which is 2. X stays as x because it's a variable. And my y-intercept b is -3. So I could put a plus right here, and I could put plus -3, but it's much better if I actually just write 2x minus 3. Okay, so that would be my equation. And then to graph it, it's really easy, because you know the y-intercept, which is your starting value. Y-intercept is on the y-axis, down 3. 1, 2, 3, so we should always label it. There's our starting value. And our rule, or our slope, is 2, so that means we go up 2 over 1, put a dot, up 2 over 1, up 2 over 1, up 2 over 1, and you can just put as many dots as you need to kind of get the feel for where the line is going to be. Also, if you want to continue the graph of the line onto the left side, which you typically do want to do, instead of going up 2 and forward 1, we can go down 2 and back 1. Down 2, back 1, and then finally we can draw a line through all of these dots. And you should probably use a ruler if you have it available, but on here I don't. Okay, there's our equation, y equals 2x plus 3. The slope is 2, so no matter where you find a spot on this line, it's always up 2 over 1, up 2 over 1. And the starting value is -3, so the y-intercept there is -3. Okay, another way that you can do this equation in slope-intercept form is if you're given 2 points on the graph. So you can imagine if I'm given 2 points, I could plot them, and certainly there's a line that goes through them. So let's plot them. -3, 4. That's back 3, up 4. There's my first point, and the other one is 1, 8. So over 1, up 1, 2, 3, 4, 5, 6, 7. Okay, that's a little tricky because it's here at, it's a little bit off the graph, but it's at 8. And this one was at 4, -3, and this one's at 1. Okay, so there's a line that goes through these 2 points. And I want to find the equation of it. The first thing I can do is find the slope by looking at my rise and my run. So on my graph, I can see that I'm going from 4 up to 8. So my rise was 4. And for my run, I'm here at -3, and I'm going all the way over here to +1. And the distance from -3 over to +1 is also 4. So my slope, which is rise over run, so from the graph, again, this is from the graph, is up 4 and over 4, which is equal to 1. Now, another way that you could find the slope, suppose you weren't given a nice little piece of graph paper or a space for you to draw the picture, you could still figure this out just using these 2 points. So the concept of slope is rise over run. So if you have a graph, you can do that. But the equation for it is y2 minus y1 over x2 minus x1. And you can also just use the equation without actually visualizing it. So y2 minus y1, I'm going to do 8 minus 4 over x2 minus x1 is going to be 1 minus a -3. 1 minus a -3 becomes positive. And again, we get 4 over 4. So again, we get 1. Okay, so that's kind of handy. We found the slope either mathematically using this equation or conceptually and graphically using this equation. And we know the slope. So we can write the formula. We can find the y-intercept. So we know the slope. So we can write y equals mx. Instead of writing, plus b. Okay. So now, I have this coordinate point, and I have this coordinate point, and I know that m equals 1. Okay, so to find this y-intercept, I can plug in what I know, which is m equals 1. And I can use either this point or this point. It doesn't matter which point you use, because both of these points are on the graph, so both of these points are going to yield the same y-intercept. And just real quick, you can see by looking at the graph that the y-intercept should probably be 7. Since this point is 1, 8, if we go, and the slope is 1, back 1, down 1, we know the y-intercept should be 7, but let's prove it. I'm going to plug in, I'm going to choose this point. I'm going to plug in the y value is 8. My slope was 1. My x value is 1. 1 times 1 plus b. Okay, 1 times 1 is just 1, so I can just subtract 1, cancel, and I get b equals 7. So mathematically, it confirms what I can see on my graph. So now I have my m value, and I have my b value. And to do slope-intercept form, all you need is the slope and the intercept. That's why it's called slope-intercept form of a line, because you just need those two things. So 1x plus 7 is the equation of the line. and you don't have to write the 1 in front if you don't want to, but if you want to, it makes it obvious that the slope is 1. But anytime you have a variable with no numbers in front, automatically there's a 1. Okay. Alternatively, if you're given the graphs, you can work backwards to figure out what the equation was. So to get the equation in slope-intercept, we have to find the two things, our slope and intercept, which are easy to get from a graph. So let's try the first one. I can see the intercept is right here, so I can see that b equals 1 for this graph. And now to find the slope, we should try to find points that line up right on the corner. So to me it looks like this one lines up well, this one lined up well, this one lined up well, and this one lined up well. So I can check and see up 3 over 2, and we should verify that it's the same. Up 3 over 2, up 3 over 2. So it's the same for all of them, so I can write rise over run equals 3 over 2. Okay, and now I can write y equals mx plus b, and then I can fill in y equals, the slope is up 3 over 2, and my b was 1, so plus 1. You notice that before I write in my numbers, I always write down what the formula that I'm using is, both for the slope formula and for the slope-intercept form of a line. It's a really good habit to get into. Instead of just jumping straight to the numerical values of your answer, write down what the formula is that you're using. It makes it a lot easier for me as your teacher to grade it, but it also makes it a lot clearer if you're going back later on looking and trying to see what you did to study for a quiz or a test or explain to a classmate how you did it. Those are all very helpful things to do. Okay, let's try the second one here. So this one, it's not so easy to see what the intercept is. You know, you can look right there and you can kind of say, uh-oh, you know, clearly there's intercept 1, 2, it's like 3.5 or 3 2/3 something, but it's not very easy to see. So let me show you how you can get the intercept on these that are not so easy. First, you want to try to choose some points that look like they're solid. So this one, this one, this one, this one, all those look good. So let's find the slope. So the slope is, again, rise over run. So I'm going to go down 1 over 3, down 1 over 3, down 1 over 3. That's consistent, so down 1 is -1, over 3 is +3, so my slope is -1 over 3. And now to figure out what that value is right there, I can use one of these known points, like this point right here is 2, 2. Okay, so I can use this point 2, 2, and this slope -1/3 to figure out the value of b. So using y equals mx plus b, I can write y equals mx plus b. Then I can write 2 equals, what's my slope? -1/3 times the x value, which is 2, plus b. So -1/3 times 2 is -2/3. So to cancel out this -2/3, I need to add 2/3 to both sides. Add 2/3. Okay, so those cancel, and I get that b equals 2 plus 2/3, which is, of course, 2 2/3. So I know my b value, and I know my slope, because I found that before. And so again, we're going to go this way. Y equals slope, -1/3 x. B value plus 2 2/3. So there's the equation of the line. So sometimes, you know, you have to do a couple of more steps in order to find the things that you want to find, but you can always use this equation y equals mx plus b, plug in the things that you know, maybe a point and a slope or a point and a y-intercept, and you can solve for the things that you don't know. My last comment about this slope-intercept formula is when you're writing m times x, the x is always in the numerator. So when I have something like -1/3 x, I have to be careful not to write -1 and then put the x down here. So this is bad. Same thing when I have 3/2 x. It's 3/2 times x. That's good. If you do 3 over 2x, that's really bad. So it's important. You could, so this is, this one is bad, this one is bad, this one is good. Another thing you could do is you could do 3x over 2. That one is okay. As long as the x is in the numerator, it's okay. If the x is in the denominator, then it's not the same as what you want it to be. Because if it's in the denominator, think back, we learned something where the x was in the denominator, and that was called inverse variation, which is very different than linear equations. Okay, that's it for slope-intercept form of a line. I hope these examples have helped you understand it, and let me know if you have any questions.